Okay, so good afternoon, everyone. My name is Sumit Kumar. I am PhD research scholar at IIT ISM Dhanbad. This is a course named Geotechnical Engineering, which I am going to take during this session. Those who are enrolled in this course can go through my lecture over here in the live classes as well, and they can ask the problem. Otherwise, the lectures are also uploaded on YouTube by me, and they can go through over there as well. And if they are not available at this point of time to take the classes, so that's not the problem. And some more points I will add over here. That is, this class will be going to take place every Saturday from 3 to 5. And all of you who are over here or who are seeing this video on the YouTube can go through these classes on the same day. I will upload on the YouTube as well, and you can go through over there and can ask any question over there as well in the comment section, or in the subsequent classes you can ask me if any problem arises. In the one more point is over there, like if internet connection goes off due to any problem over here and I get disconnected, I will rejoin and continue the class from there. So if such problem arises at any point of time, every participant should stay in the meeting. I will rejoin and start the meeting and carry forward the class. Okay. One more thing I will ask you that this is the course which give you the idea about the geotechnical engineering too. Most of the things, the basic thing you have gone through during the geotechnical engineering one course. Over there, the basic concepts of soil mechanics you are aware of. So over here, you will get its application part in the more instance. So I will suggest you be patient, and in this class, this is the first class, and till this time, the DN sir has taught whatever taught. I will give a quick summary and take some questions. But in this class, the question is less because the question aspects are not as much covered in the syllabus of this week. So in the subsequent classes, the question will be more and the concepts is a little less. But if you want anything to ask regarding whatever the doubt in the class earlier, which I have uploaded on the YouTube, we have gone through, so you can ask me at any point of time. One additional point I want to add on over here, like the presentation which I am presenting over here is also shared with you through the Google Drive link, which will be shared with you by the NPTEL team itself. And if you are not accessible to that, you can write in the chat box. I will give the link over here, or maybe I will insert that link in the YouTube as well, YouTube description box as well. So that's it from my side. Now I will start the course. Okay, I think so. This much introduction is sufficient, and I see that few people are here at this point of time. So I will directly start, and those who are here, if face any problem regarding the communication, if the language is, the voice is not audible or anything else, you can communicate me at any point of time. That's not the issue for you. Okay. Okay. So I will start from here. So our course name is Geotechnical Engineering Group, and this is taken by Professor D.N. Singh sir from IIT Bombay, and this course has been taught in so much simplicity that if you have gone through the lecture, you have understand that the practical implementation are taken care of at each point of time during this coursework. So first of all, I will start the basic concepts regarding the course which we are going to take on, like geotechnical engineering. So first of all, what is the geotechnical engineering? Geotechnical means in geotechnical engineering we are talking about the soil. The soil mechanics is the geotechnical engineering in itself. At some places, the soil mechanics 1, soil mechanics 2 is also said. At some places, geotechnical engineering 1 and 2 is said. So, in these aspects, we talk about soil, its characteristics. What are the property of soil? How soil behave? Basically, we know that all the buildings, all the infrastructure, any road network, any railway network, or every aspect of the construction business, all things are standing on the soil itself. It is not possible that we could imagine any structure without soil. Have you ever imagined that in any construction work, soil is not a participant? Basically, any structure, if we are starting from a basic building block, in the old time, the huts are constructed that are also constructed on a soil. As the advancement takes place, we are creating the structure, RCC structure, steel structure. In the subsequent times, now earlier the road are of the only the earth work are there. After that, the bricks are there. Now the concrete roads are there. So everything is established on soil. Suppose if a structure is constructed at any place and the soil below it not have that much strength that it can sustain that load which is coming over there. Taking the example of a simple road, everyone first of all, if come step out of their house, they come on the road, and that roads stand on the soil itself, and that soil also need to be have some strength. We have seen that in very past times, in especially in villages, we have seen that the road gets damaged so frequently because that are not designed. The soil aspects are never taken care of. If the roads are constructed and if the heavy loads, sometimes we see some construction work are going in any one of the houses, one or two of the houses in the village. Like so, the big trolleys or maybe trucks are coming carrying the construction material. It will damage in one or two go to do those roads. So that is a factor because the soil over there is of what characteristics, what improvement need to be done in order to enhance its capability, in order to sustain that load, is not taken care of in one way or the other. So those aspects are come under soil mechanics or geotechnical engineering. So in geotechnical engineering, we cover all aspects like the what are the soil characteristics. Starting from the if we talk about the soils, then we say what is the density, like unit weight, what is the moisture content, what is the dry density, and what is the void ratio, how much porosity is there. So these are the basic building blocks which we need to be there. Then we go in little advancement. Then we talk about the shear strength. So to find the shear strength, we talk about cohesion, friction angle. So those aspects are going hand in hand, and afterwards we get reach to a certain point over there. We will say, okay, now the practical implementation of those knowledge is going to be taken place. So the in one in one word, if someone had to say what is the use of this coursework, basically if anything we are reading the geotechnical engineering over here. In childhood, we are reading anything we ask question why we are reading. We are in school days. We used to read science, math. Many people say that we are reading differentiation, integration. What is the use of that? What is the use of sine theta cos theta? But over there also we are asking question. What is the use of that? And in the subsequent time, as you all are the engineer professional, you come to know that those aspects are implemented in the field work. In any calculation, if any slope is there over there, the sine theta cos theta we are using over there. So in the same way, we anything when we start to study, we have to ask what is the factor, what are the aspects which we need to consider while studying this course, how it will be beneficial for me, and how it will help me as a engineering professionals, or maybe uh, engineering professional, or if I am working in the any company, how this knowledge will enhance my work capacity over there. Okay, so this is the first of the most important part. So over here we are first of all talking about the shear strength of the soil. So the shear strength of the soil is that the that strength which soil have to resist the shear force. Basically, when we talk about anything, we have studied in our childhood in physics in 11th or 12th class, or before that as well. But we have talked about the some weight is kept over a place. It will be given a force to move on, so it will have a resisting force, which is a frictional force. So when it's overcome over there, the force which has been applied is more than that resisting force over there that will able to move. So in the same way, the shear strength of soil is ability of soil mass to resist the shear force. And the shear force is basically, if we see you, if you can see my hand action, the the resistance offered by upper hand to move on the lower hand is in one way or the other is the shear resistance. So in this case of soil, it is the measure of soil resistance to do deformation or failure when subjected to shear stress. In the subsequent slides, I will show you some good example with the help of figure. Over there, you find that there is a critical stress, critical shear stress. If we first of all, I give one more example. Like if you see, um, there is any structure is there. Like for example, there is a weight consisting of 80 kg and a small block which of 4 or 5 year age, who the weight that need to be pulled out from there. So the force need to be required, the some force need to be required to push it from one place to other. So he apply a force, and during the application, sorry, during the application of force, that force must need to be more than the weight of that body in order to move it. Similarly, in the shear strength, the resisting force is there with the soil. It depend on its cohesion, friction angle. So when its resistance overcome, it will allow to move. So the shear strength is one of the most important property in the geotechnical engineering. It determines the stability and the load bearing capacity of the soil structure, and it is very much helpful in the all aspects of the geotechnical factors. If you talk about foundation, we talk about retaining walls, we talk about soils, everywhere the shear strength is the most important factor. On the basis of that, we will say that how much safe this structure is, if any structure are constructed over there, how much the factor of safety is there. Okay, so now we talk about the parameters through which we calculate the shear strength. So the two of the most important parameters are the cohesion and angle of internal friction. Cohesion represents the shear strength of soil particle due to the intermolecular force and is more significant in the cohesive soil. As name suggests over here, okay, I think I am audible. Hello, okay. Huh. So, as the name suggests, the cohesion is the factor which is responsible for the shear strength, which only depend on the cohesive soil. And the cohesive soils are likely. Okay. Now we talk about the second parameter, that is the angle of internal friction. The angle of internal friction represents the resistance of soil particle to the sliding, and it is the most relevant in the cohesionless soil like sand. So one more question arises over here, because the answers are lie in the question itself. If we ask a question, then we get some answer. So the second question arising over here is, okay, no problem. Is there some soil which might have some cohesion as well as the angle of internal friction? It is not like that, no. At some place the cohesion is 50 kilopascal, and the angle of internal friction is 0, and at some other place the angle of internal friction is 30 and the cohesion is 0. It may be case at some places, but in the most of the cases, it has been found that some cohesion factor is also there and angle of internal fraction is also there. So both combine to give a strength to the soil. Basically, these are the parameters which we calculate. The soil have the strength. These parameters could be calculated with the help of the triaxial test or the different test which we are going to read during this course. So those factors are the most important aspects made this soil, which made this soil, and by which we are able to get the strength of the soil. Okay, moving ahead. Okay, slides are not moving over here, I think so. Okay, now as I am talking about it, how these parameters could be found. So the shear strength of soil can be determined through the laboratory test, and the laboratory tests are like triaxial test. In triaxial test, what we perform, we see step by step each and every part of the triaxial test, direct shear test. So I will give a brief overview. In the triaxial test, there are three tests like UU test, U test, and CD test. So we will talk about that in detail in the subsequent slides, and in more detail in the next class as well, because over there that part of the syllabus has been covered, and we will also solve the problems, solve some very good problem on these two aspects, because as per my knowledge, at the end of this course you all have to go through. I am talking about you all have. So over here the few people are there, but the other people who are going to see this video over the YouTube, and go through these presentation files which I will upload. So they will get to know that how much important things which we are covering over here. Basically, the everything is interrelated in one way or the other. Because if you could try to start with the third lecture itself, it is not possible that you will cover everything. Over here, this must be the introduction class, the first class. Over here, the numerical problem are less. But if the theory aspects are not clear to you, the numerical aspects could not be covered by you. If you have gone through the lecture of the sir as of now, you see over there the at every point the practical implementation is discussed by sir. So in the similar manner, the practical implementation with the help of theory has been covered to similar in that fashion as well. You need to understand the theoretical aspects to understand the practical work. Okay, so there are the tests like the triaxial test, direct shear test. So in triaxial test, the three type of test is there, that is UU test, U test, and CD test. Unconfined and consolidated, consolidated and consolidated, and these are three tested. And in direct shear test, we apply the shear force. In direct shear test, the one of the major limitation, that is the predefined shear failure surface is already there, and the failure takes place from that section only, and it is known to us. So this is one of the major limitation over there. In direct shear test, measure the soil response to applied shear stresses, and these tests help the engineers or the designers to design the safe and stable structure considering the shear strength properties of the soil. And these parameters, which we have discussed in the previous slide, like the cohesion, angle of internal friction, are one of the major parts which we are able to find through the help of the triaxial test or the other laboratory tests. Okay, I think so. Everything is audible and all can hear me clearly. I hope so. Okay, so I will move ahead in the same manner. If any problem is there regarding any or like if I am not audible at any point of time, or maybe the slides are not moving, anything happen, I will check by myself as well. I have also see observing from the other system like it has been going smooth or not. But if any problem is faced by any one of you, you can ask me anytime. I will try to resolve the issue. Okay. So I am moving ahead. So, as first of all, we have discussed about the importance because anything which we are studying must need to have some importance. Because without importance, if we are taking anything, it doesn't matter. In day-to-day activity also, we consciously or subconsciously always ask that is it important for me? In subconsciously we ask, but sometimes we also ask consciously. So conscious decision in that regard will always be helpful for us. So okay, so I will start with the importance. So the safety of any geotechnical structure depend on the strength of soil. Basically, every soil has some strength, and the structures may be the multi-story building, some bridges, some tunnels, some roadways, or maybe some institutional building like schools, colleges. Everything stand on the soil. So first of all, we need to find the strength of the soil. As you know, if some of you are working in the any companies, you see that before the construction of any structure, first of all, they will call for the soil report. First of all, the company do the soil investigation, do the boreholes, find the soil parameters like the unit weight, and they also find the cohesion friction angle. They also find that how much strength is over there in the soil itself to sustain that load which has been applied on those structures. So it is very important that the soil must have strength because if the soil doesn't have strength and we construct any structure, it may get settle over there, uniform deformation may take place. I'm taking about one example. You have heard of Josimat previous year, this time only. The Josimat case is there. Over there, you have find that the all the buildings have developed some cracks. I think so. You have remembered these aspects because that is very much in news in this time only. In the month of either July or the first week of August, that problem arises. So over there, you see that the cracks get developed in the buildings, and that's why because over there also the settlement takes place. Maybe region may be different, that is not strength, maybe due to some construction activity or whatever the factor. That's I am not dealing with over here. But the walls get cracks. You have find that those cracks develop. So in the similar manner in a flat area as well, if the soil characteristics is not up to mark and the weight is applied over there, maybe settlement takes place at one place and the another place remain less settled than that. There is a crack get developed in the walls or maybe in the columns, which result in the damage of the structures and all the cost which has been implemented to construct will go in vain. So it is very important to find the strength of the soil before moving ahead. So what are the problems arising? If a soil fail, structure found on it can collapse as I discussed over here, and it may also cause danger to the lives and economic damage is also there because in the construction of those structure the large amount of investment is already made. So it is very important for one and all to find the strength of soil before construction over there. Maybe a simple building, simple one-story building one is going to construct. The strength of soil is very important because if those structures lie in the earthquake zone or maybe soil will be equivalent soil, we will discuss about those things. What are the equivalent soils? Little bit we touch, but that is not the part of syllabus over here. But if the soil is liquefiable, if some earthquake zone is there, if earthquake get happen, that may also lead to the big dangers. So that is very important that we should understand the aspects of soil first of all before the construction of anything on those fields. Okay. So the strength of soil is most important for the geotechnical engineers or the professional. And the when we talk about the word strength, so it's mainly means shear strength in soil because when we talk about strength, In the aspects of soil, we talk about the shear strength, and which depends on the internal friction. The which is the internal frictional resistance, or and as we discussed first in the very first slide, that how much it is important to understand the parameters which affect the strength of the soil. So the shear strength required to make the estimates of the load bearing capacity of soil and the estimates the load bearing capacity of soil and the stability of geotechnical structure, and in analyzes the stress strain characteristics of the soil. Okay, so I will take a pin over there here, because if something I need to add on, I can add. Okay, I will take a laser pointer over here. So the shear strength is required to make the estimates of the load bearing capacity of the soil and the stability of geotechnical structure in analyzing the stress strain characteristics. So over here in the subsequent slides in the today class itself, we are going to talk about what is we are going to talk about what are the most important factors. We are talking about the Mohr circle. Okay, am I audible now? Hello? Yes. Okay, see. So now we talk about the importance of shear strength. We are talking about the importance of shear strength only. So the shear strength is a critical factor in the geotechnical engineering, as it determines the stability and behavior of soil under the different loading conditions. And understanding the shear strength is essential for designing the foundations, slopes, retaining walls, and other structures. Because the everything depends on the soil, and soil have the strength, that is the shear strength, which amplify the factor of safety over there, and that how much load it can sustain. Now we are going to see some diagrams with the help of which you can understand these factors very easily. So the shear strength play a very crucial role in preventing the failure such as the landslides, embankment collapse, and the foundation settlement. Because the knowledge of these factors only will help us in understanding the extent of damage we could reduce before designing the structures over those soils. Now talking about the shear strength in the granular soil. So the granular soil such as the sand exhibits unique behavior under stresses. As we know, the sand and the clay, or the soil which only get the strength from the friction and from the clay behaves little bit differently, and there the level settlement on the sand and the clay is also different. When we talk about the settlement allowed for the clay or the sand is different, as we know that those have the particle sizes of different, so it will behave also differently under the stress. Okay, so in the flexible boundary containers, the granular soil tend to flow when it's subjected to stress, while in the rigid boundary container, the volumetric deformations occurs, leading to changes in the shape and the density of the soil. Crushing, bending, and rolling mechanics can also affect the strength of the granular soil in one way or the other. Okay, now the cohesive soil such as clay, as we have talked about the cohesionless soil, so we also talk about the shear strength in the cohesive soil. So the cohesive soil such as clay requires a special consideration in terms of the shear strength. The compaction characteristics are crucial. Compaction characteristics are crucial in achieving the desired shear strength in the cohesive soil. Decreasing the permeability and preventing the consolidation settlement are the key objectives in the compacting cohesive soil. Development of the shear stresses and slippage is the common in the cohesive soil under the excessive load. Okay, see my slides are visible now. Okay, no problem. I think so. Slides are visible. Let me check again because I don't get you. Okay, so it's okay. It is visible. I can see from my system as well. Okay, so we are talking about the shear strength of cohesive soil. Okay, let me recall this slide as well because I think so some connection problem is over there. So the shear strength in the cohesive soil. So cohesive soil such as the clay requires special consideration in term of the shear strength. Compaction characteristics are crucial in achieving the desired shear strength in the cohesive soil. Decreasing permeability and preventing the consolidation settlement are the key objectives in compacting the cohesive soil. The development of shear stress in the slippage is the common in the cohesive soil under excessive load. Okay, now we'll go ahead to talk about the excessive loading and the shear failures. Okay, I have doubt that whether the slide is visible to you or not. Let me reshare my screen because I don't get you. I will stop editing and reshare my screen. Okay, excessive loading and shear failures. This slide is visible now? Yes. Okay, so the excessive loading and shear failures. Excessive loading can lead to the shear failure in soil, which can have the severe consequences because if the loading which has been applied in more than the load which are allowable will lead to the failure of soil, leading to the damage to the structure. So the initially settlements may occur due to the applied load, but beyond a certain point, the shear failure can take place because when we talk about the strength, as we are most aware, like for example, a structure which can sustain. Take an arbitrary example. For example, if a structure is there which can sustain the load up to 100 units, so if we apply the load more than 100 units, if we apply the load 90 units, it will sustain. There is no damage takes place over there. We apply 95 units, no problem. 96 units is also acceptable. If we apply 99.99 units of load over there, it can sustain in that position only without any problem. But if we increase the load from 99 to 100, it is on the verge of failure. And if the load just exceeded from 100 to 100.1 only, it will get collapse. But one additional point I want to add over here. In any engineering design problem, engineered problem, basically the design problem, engineered problem, the problem which has been designed by the engineers, a factor of safety is always there. but it doesn't mean that we will consider the in other way. We will say that the structure will fail on this much load only, like the 100 unit load only. We can't say that the factor of safety is 1.5, so it can fail on 150, because extra factor of safety is given for the adverse condition. It is also said that okay, it is also said that the excessive load, the extra load is over there. The extra factor of safety is just provided in the adverse condition, because when we talk about soils, its behavior sometimes in a test result maybe get not as it could be found, may lead to the some problem. So that's why the extra factor of safety is always given in any structure. As we talk about in the civil engineering, we talk about the soil structure. First of all, every structure stand on soil, so we talk about soils. So that soil must have some strength, and that strength completely depends. That strength completely depends on the parameters of soil. That is its unit weights. Afterwards, as we talked earlier as well, the test, different test. If you talk about the shear strength, so the different tests like the triaxial test, direct shear test, and many more tests has been performed to find those parameters in order to find the shear strength of the soil, and on the basis of that we design our structures over there, because the soil must have some strength, and that strength needed to be replicate before the constructing any of the infrastructure project over there, because without those factors consideration, if a structure has been designed, it may lead to the damage to the structures on those fields. Okay, so I get deviated from the main point over where we are talking. So we are talking about the excessive loading and the shear failure. So the excessive loading can lead to the shear failure in soil, which can have the severe consequences. We talk about the what could be consequences. So the as we talk about the consequences, like it will lead to the failure in different places. If we talk about the slopes, there may be slope failure. Some landslides may take place. If we talk about the foundation may get collapsed. If we talk about roadways, if the soil has not been properly compacted to the that dry density which need to be achieved in order to sustain the specific load. So all of you must have seen the construction of roads. Maybe in your hometown, or maybe if you are going across towns, some highway construction you have seen. You have seen that the very heavy structures are over there, and the soils are also being from the other places as well in order to build those structure in a suitable manner. Because if the soil is not as acceptable over there, some ground improvement technique need to be implemented in order to make the soil that strength. And it is one of the most important factors when we talk about soil improvement. It doesn't mean that if the soil improvement implementation has been done and soil has got its strength. After the implementation of soil improvement technique, we will retest the soil whether it has been achieved, which we are trying to achieve. If it get that much strength afterwards, the implementation of subsequent stages takes place. Especially if we are talking about the roadway or any construction at any construction sites, if the construction place is work is going on, the first of all the soil test has been performed in order to find the parameters. On the basis of that we will determine its strength before uh, going to the subsequent stages, like how much loads it can under withstand. If the more load need to be stood over there, so it is most important thing to replace those while or may apply some improvement technique. Okay. So initially settlement may occur due to the applied load, but beyond a certain point, the shear failure can take place. Shear failure can result in the landslides. We have talked about that, rock falls, embankment failure, and the other different adverse problems could also be arise, like the foundation failures and many more things we have discussed in the some slide earlier as well. So understanding the factors contributing to the shear failure is crucial in designing the safe and stable structures, and we as engineers, we as a civil engineers, geotechnical engineers, we must have to understand those aspects. So moving ahead, okay, I couldn't change my slide. Am I audible? Hello? Okay, give me a second. Okay, so we are talking about shear strength. We will go ahead in that fashion only. So the shear strength of soil is a fundamental concept in geotechnical engineering. We have discussed this point in different words at many point of time from very first slide as well. So the understanding the behavior of granular and cohesive soil. We have talked about the granular, like the what are the factors which are over there, what are the factors with the cohesive soil in the fourth slide of this study work. Okay, so understanding the behavior of granular and cohesive soil under the stress is essential for designing the safe and stable structure. And in the subsequent classes, we will going to study the test. And in this class only, we are going to solve some problem as well based on the what are the stresses in the form of the direct formulation as well. And the Mohr circle method is also discussed. Okay, so the excessive loading can lead to the settlement and the shear failure. Okay, excessive loading can lead to the settlement and the shear failure, which can have a severe consequences. We talk about the triaxial element analysis. So the triaxial element analysis why we perform. We talk about the triaxial test over there. I have told that the CU test, CB test, UU test are there. So in that case, the actual environment need to be created, which has been going to be there in the field in the original condition over there. The load has been applied. So the triaxial element analysis help in studying the shear failure and identifying the critical failure planes, because we know that the soil body is there, like a big soil structure is there, so it is not no, that it can fail from any place. It may be possible at some places its strength is okay, like it can sustain the 120 unit of load, and at some places it can take almost 150 unit of load, and at some point of time it can take the 90 unit of load. So the failure, when we apply the load as a whole, the failure first of all takes place at on that surface which can sustain only 90 unit of load. So it is very important to identify the critical failure surface as well during the study of these aspects. So that we could be find with the help of tricycle. The shear strength is one of the key factors in designing the foundation, slopes, retaining wall, and the different geotechnical structures. Okay, so we talk about the state of stress in soil. So the state of stress in soil is described by the normal stress and shear stress. Okay, and we will talk about that how we calculate it, how we find the principal shear stress, how we find the maximum and minimum, how in the Mohr circle how we find the origin, in Mohr circle how we find the shear stresses like Tomax. So we are going to discuss all those things in the today class only, and some problems are also there at the end of the slides. And one more point I want to add on that some questions I also provided at the end of the slides, and these slides will be shared with you through the Google Drive link. I will upload over there in today only, so you can access those slides. And this video is there on the YouTube, so you can go across these slides as well. And if you are able to solve those questions, and the questions are very simple. If you are able to write those questions, you will find a very good clarity and conceptual clarity, especially on the subject. Okay, so I will go move ahead. So the stresses are result of the external forces acting on the soil mass. The critically of the soil mass leads to the formation of planes where the stress are concentrated. Each point within the soil mass experience the critical stresses simultaneously. Okay, so I have talked about this. as this is also discussed in the class as well, if you have gone across the video. So see, the load has been applied, and the overall, if you can see, if you can imagine this 3D body, imagine it as a 3D body. You can see that the failure takes place at a point. The load is applied over there. There is a section which has been detached, the detached from the original body, and other section. Okay, I think so. It is visible to you. Okay, so one is a detached body. Okay, some spelling mistakes in there. No problem. Okay, I think so now it is visible and clear to one and all. So one is the parent body and other is a detached body. So you can see from this slide the load has been applied, and as I have discussed in the earlier example as well, like the load has been applied to over all structures, and but it fell from the specific section. That section is critical section. As we discussed in the previous slide, during the stress calculation, we have to find the critical surface from where the failure takes place, and after determining that critical surface, we are able to found that the how much load it can sustain, because the minimum load which it can sustain will be said to be its strength, because the failure takes place from that section. So our structure, if we construct any structure over there and the load is more than that, it will going to be fail. In no case we are able to save our structure. So it is very important to understand that the how much load we could apply on any structure before its failure. Okay, so over here you can see in the right hand side the tau and tau critical loads are there. So I have given the example earlier as well. I will state it again. What is that example? Like if a load has been applied, if a critical load, for example, critical load is that load where the failure takes place. And so over here, if we are talking about stress, the critical stress is that stress up to which the our structure is safe. If the stress, shear stress which has been applied is increased from the stress which are already acting on those structures, it will lead to the failure and ultimately result in the failure of whole structure which are standing on those sections. Okay, so I will show you some real images over here. So you can see from this image, if it is very clear, like both the parent and detached body is over there, you can see that this is a road, and road or there is a road thing, but a failure play takes place from a specific section. But what are the region? Is there any reason that it fails from this point only? Why it doesn't fail from any other places? Because it is a critical failure surface over where the load could not be sustained, so it will result in the failure from this section only. So it is very important to identify the critical failure surface before moving ahead at any point of time in order to identify the critical failure surface. We can conduct the tri-axial test, and the tri-axial test give us the clear aspects that what are the critical surfaces and how much strength the specific soil have. Accordingly we can move ahead. There is another picture which has been showing that the detached body is there and the parent body is there. Over here also a failure takes place. And you can see this is a long bench of road, but the failure takes place from this surface only. So it is a critical surface for this, and the critical stress is overcome by the applied stress over here, resulting in the failure of this structure. Okay, so we are talking about the triaxial state of stress. So before moving ahead, uh, I will suggest you to take a 5 minute break, and we will come again and then start from here only. So there is a 5 minute break from here, and we will meet again after 5 minutes. I will request not to leave anyone. We stay in the meeting. I will again start teaching you from here in 5 minute break. After 5 minute break time, so please be with me. Please wait for 5 minutes. Afterwards, we will start again. Okay, we will start from 4 5. Hello, 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 hello. Okay, welcome back everyone. I will start. Okay, I think so. My slide is visible. Okay, so I will start from here, and I observe over here some new people joins in a meanwhile from starting to over here. So I will again state some important points like we are studying geotechnical engineering too, and it is one of the most important subjects considering the aspects of civil engineering as well. And if you are the expert of this geotechnical field, so it is one of the most important things we need to understand. And until here, we have talked about the shear strength, its importance, what are the parameters which required. We have also briefly discussed the test names only. We will discuss about the test in the subsequent classes. So I will request everyone to go through, and those who have joined recently and couldn't get the entire lecture, so they can go through this lecture, and this lecture will be uploaded on the YouTube by today evening or maybe by tomorrow, and the link will be shared with you. So I will request you all, if those who are not there over here may go through the YouTube link and can found and these lectures useful for all of you. And one additional point I will want to add on over here, that is the presentation file which I am taking over here will also be shared with you with the help of Google Drive link, which will be shared with you already by the NPTEL team. As I know, so I think so we can start from here. So I will go two slide earlier, the image which I have discussed, so that I found two more new people is there. So the basic aspects I can start from there, so that no one will miss anything up to that extent that anyone found that no, it is a new thing. So I will go two slides back and start from there. Okay, so over here we are discussing about the state of stress, and after that we came along the failure surface. We talk about the tau and tau critical. So over here we have discussed that point that on a soil the load has been applied and the failure takes place from the specific places. It is not like so we have to identify the critical surfaces as well, and in the triaxial test in one way we are able to find the critical sections from where the failure takes place. So from this diagram you can see that we will see the real images as well in the subsequent slides. So you can see that the parent body remain at itself and the body get detached will be on the right hand section. So, this must be the some amount of stresses which has been applied over there, which will be applied over there in order to detach this body. If the force is not there up to that extent which overcome the strength of the soil at that place, it is not possible that the failure takes place at this point. So the tau, the applied force is above the critical force. The critical force is that strength of that soil which with it can withstand, so the failure takes place of that section. Okay, you can see over here the images as well. In this image you can see the detached body and parent body is clearly visible, and you will able to find that the detached body takes gets separated from the parent body from the specific section. It is not the case that it could be filled from the any section. So in one way we can say this is the critical surface from where the failure takes place. So the strength of soil, if you take the cross sections, of 5 or 6 meter or maybe 10 meter 20 meter. We said in 20-meter section, this is the most critical section. Over there the strength is minimum, so the soil get filled from here. Okay, okay, I think so. Okay, so I will move ahead. So this is the similar diagram again. Over there, the parent body, detached body, and critical setup. I have discussed this thing earlier before taking my break. So I will discuss briefly over here for the new person who joined. I found two new people joined in the meanwhile. So that's why I will discuss again. So I will go ahead. Okay. So we talk about the triaxial state of stress. From here onward, the triaxial state of stress we will discuss. Over there, we will discuss the Mohr circle problem. We will discuss how the Mohr circle problem gets solved, how we are able to find the maximum principal, minimum principal stresses, how we are able to find the maximum shear stresses, and subsequently we will end our today class. And afterwards, we will meet in the next class over there. In the end of this class, we will solve some problems, numerical problems, which are the key aspects which we bring from today class. And in the subsequent classes, then we discuss about tested and the problems which get generated on the basis of those tests will also be discussed. Okay, so I start from the triaxial state of stress. So the ground surface exerts a stress on the soil in three directions, creating the triaxial state of stress. The geotechnical material like soils are assumed to be isotropic homogeneous, although the assumption may not always hold true. We know that we always assume the soil to be isotropic homogeneous, but this assumption not always hold true. We know this from the basic soil mechanics concepts only. So I don't think it need to be explained in that manner over here. So to simplify the analysis, the presentation focuses on the 2D situation known as the plane strain problem. We will discuss there is sigma 1, sigma 2, sigma 3. As we already said that in the triaxial test, the sigma 1, sigma 2, sigma 3 will be there, but in this case, only the sigma 1 and sigma 3 we will discuss about. We will say that as we see, there is for example, there is a cylindrical surface is there. The soil sample is in the cylindrical fashion, and in the triaxial test, the stress is applied from the all direction. If you see, there is a cylindrical section like this, and the stress is applied from. If you are able to see my hand, if the stress is applied from all sides, this only this cylindrical section. Okay, I will show something else, so you will found it clearly. See, this is a okay. Is my image I think so visible? So it is a surface over here. The stress has been applied. The deviating stress is applied from upward from this direction. I think so. It is visible. So and deviating stress from applied from upside, and the two stress, that is the sigma 3 or sigma 2, are applied from all directions in the same fashion. Okay, so in that case the sigma 2 and sigma 3 will be the same, so we will consider it as a plane strain problem. We consider only two stress for calculation, and on the basis of that we are able to find the parameters, like we find the relations like sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2 c tan 45 plus 5 by 2. What are that? I will discuss in a very explanatory manner in coming slides. So be patient and see the slides. Okay. So we have taken the 2D situation known as the plane strain problem. In plane strain problem, the effect of stress perpendicular to plane is ignored. What I have discussed right now is that thing only. Okay. Now we are carry forward in the same point, that is the most engineering structures are the two-dimensional in nature. Although they may appear three-dimensional, two-dimensional cases are the more prevalent in engineering practice. We always see that if we can do calculation in the two dimension of the three-dimensional problem, we always prefer the two dimension, because the calculation and the problem solving aspects is more confined and more easy in the two dimensional as compared to three dimensional. Three-dimensional problem can be simplified by considering a slice of the soil mass So over here the sigma x, sigma z and tau xz is considered, and alpha, that is a key aspects component, the two dimensional cases. Over here the sigma, that is the normal stress, and tau is the shear stress, is a function of the terms like the sigma x, sigma z and tau xz. Okay, okay. I think so. Slide is visible clearly. Okay. So now we talk about the conversion of forces to stresses. So how we will convert the forces to stresses? What are the correlations? So I will request everyone to keep their mic off because it will create intense over here. Someone mic is on. Sorry, give me a second. I will request everyone to mute their mic, please. I will request everyone to not switch on their mic, please, because it will create a little bit problem. So please be there, but don't open your mic. Okay. Now we move forward and request everyone to keep their mic switched off. If any problem is there, you can write in the chat box. I will connect to you. And one more thing, if any point of time slides or my voice is not audible to you, you can say anytime by switch on your mic. But otherwise, keep your mic off until in any question is there. If any question is there, I will request you to ask the question at the end of the class, because over there a good discussion could be taken, because what are the content of what I have prepared will be finished by then. Okay, so I will move ahead. So in geomechanics, the engineering science and the technology, the forces are converted into stresses. We already know. So, the stress provide a more convenient way to analyze the behavior of soil mass. External forces are converted into stress, that is the sigma and tau, and represented on the plane. Tau is nothing but the sigma x minus sigma z by 2 into sine 2 alpha, whereas the sigma equal to sigma x plus sigma z by 2 plus sigma x minus sigma z by 2 cos 2 alpha. This is the standard relation. You must have gone through these relation in the structure as well. We will derive this relation also in the coming classes, but as of now you will understand this in the Mohr circle. I will explain up to such extent. Afterwards, during the test, we may derive these relations, but may not be derived depending on what are our aspects. We may cover more problems, so the derivation part you can go through from the lecture of the sir. But if that not possible, I will cover over here as well. We will see that how much time we will get to cover those aspects, so I will cover. As of now you know this formula, and I think so you get derive this relation during your strength of material class. Okay, so you see over here the equilibrium equation of Mohr circle. So you can see that the equilibrium equation are used to analyze the state of stress in the soil. The equilibrium equation involves the relationship between the normal stress sigma and the shear stress tau, and the equation can be represented graphically using the Mohr circle. Over here you can see that the sigma 1, sigma 3 are there. The x axis is nothing but the sigma axis, that is the normal stress, while the tau axis is the shear stress. Over here you can see the sigma 1 and sigma 3. If I want to specify these terms sigma 1 and sigma 3 specifically, we will say sigma 1 is the principal shear stress, while the maximum principal shear stress sigma 3 is the minimum principal shear stress. And how we are able to calculate this in the other form, we also know that how we are able to find the origin of this Mohr circle, and with the help of that, with the help of the knowledge of the sigma x, sigma z, tau x z, which we are talking about earlier, we are able to found everything in and anything which are required, because I studied a relation. If someone of you are little bit aware about that relation, which is interrelating sigma 1 and sigma 3, as sigma 1 equal to sigma 3 10 square 45 plus 5 by 2 plus 2 secant 45 plus 5 by 2. You can see, if you know sigma 1, sigma 3, or one of the aspects 3 or 5, you know the soil is the cohesive, so you can over there the 5 is 0, so you can actually found the cohesion if sigma 1, sigma 3 is known. And conversely, if we know the C is 0 and the phi could be find at how much the angle of internal friction is there on the basis of sigma 1 and sigma 3, and sigma 1, sigma 3 could be found from the help of triaxial test as well. So we will go ahead in that direction. If you are aware, you understand what I said. If you are not aware, that's not a problem, not to worry, because those aspects we will discuss in this coursework. Okay. I will go and see talk about some more. I will talk about some more point about Mohr circle before moving to the Mohr circle. So in this presentation introduces the Mohr circle as a graphical tool used to analyze the state of stresses. Mohr circle help us to determine the stress component sigma and tau at a given plane inclined at an angle alpha. And what is that? The physical representation is also there. In the subsequent slide, I will show that. And the steps to solve the problem using the Mohr circles are also one of the method over there. The we solve the problem analytically. It is one of the analytical method over there. With the help of analytical approach, we solve the problem to find the sigma 1, sigma 3, and tau and sigma and tau. Okay, talking about the property, the Mohr circle must have some property. What are the property? So the Mohr circle always known to be one of the powerful tool for understanding the state of stress in materials, applicable to different materials like soils, rocks, and composites. We know that we talk about these factors in the strength of material course as well, because over there the materials is there, composites is there, so that is applicable over there as well. And here the soil is the three phase system, solid, liquid. So over here it is also applicable. So we are discussing over here. Mohr circle analysis combined with the material properties. Mohr circle analysis combined with the material properties such as the shear strength allow for the analysis of the real life situation in civil engineering. Okay, now I will show one of the images to you. So with the help of that, you will get a little bit idea of what we are going to talk about. Okay, okay. So I will see. Am I audible? Okay, I am audible. See, over here the sign convention has been represented. So you can see this sign convention is used for the calculation. And if any one of you over there know the sign convention, so you will understand that this sign convention is very much similar to the the convention which we have gone across during the strength of material course. So, sign convention for shear stress used for the construction of Mohr circle has is shown over here the positive shear stresses, the positive negative shear stresses, and how we found the alpha. Everything we will see in the subsequent slides in one by one. So, the shear failure is one of the simplified solution, and it is a common mode of failure in soils. In simplified solution, the focus is on the shear failure and the rigid body behavior. The Mohr circle is used to analyze the state of stress in soil undergoing shear failure. There are some assumptions over here, like if sigma x is considered to be sigma 1 and sigma z is considered to be sigma 3, that is the major and minimum principal stresses respectively. You will see this in with the help of a schematic diagram as well. I will show you in subsequent slides. Give me a minute. So, okay, I will talk to you in a minute. Give me a minute. Okay. Okay. See, we talking about a generalized solution. We have said that the Mohr circle is a generalized solution. So, understanding the state of stress in the soil is a critical for the geotechnical engineers. The Mohr circle provides a useful tool for analyzing the stress and failure in soil. The simplified solution, generalized change, and help in the practical implementation. And how it will help, we will see with the help of some examples over there. We solve some problem and we are able to get the how that will help in solving the real life problem. Okay. It is Mohr circle define the state of stress acting at a given point which is sitting on a plane along which the failure is about to take place. And the talking about the Mohr circle analysis, the deriving the relationship between the sigma square and the tau square as a circle equation and how it happens we will see in, in the help of the schematic diagram. The interpretation of the Mohr circle and its representation of state of stress in a material over there as we talk about the principal stresses is sigma 1 that is said to be major principal stress and sigma 3 is the minor principal stress. Mohr circle define the state of stress at a point on a plane where the failure is about to occur so that over here we are able to find the critical section from where the failure is going to happen and the practical application of Mohr circle is analyzing the equilibrium in the various material. Okay, so over here now I will show you one of the images. With the help of that you will get a better understanding. Okay, give me a minute. I'm not able to move my slide due to some problem. Okay, I think so. The image is clearly visible to you. Yes. So you can see over here, the Mohr circle has been drawn. The x-axis is the sigma axis and the y-axis is the tau axis. Over here you can see as I already said you that the sigma 1 that is said to be principal major stress, sigma 3 is said to be principal minor stress and the shear the normal axis is the axis over there the shear stress is 0. From the simple mathematics you also know that the x coordinate x on x coordinate if any point is exist over there the y coordinate is 0 so you can see the principal major stress point sigma 1 over there the coordinate is sigma 1 0 while the principal minor stress point the coordinate is sigma 3 0. So it is very much clear that is this at this line whatever the stress is that is 0 on the y-axis. That's why this axis is said to be zero shear stress plane. One more point from this diagram only. If you think mathematically, so the coordinate sigma 1 0 and sigma 3 0 on the x-axis, if we subtract these 2 points from sigma 1 minus sigma 3, we find the diameter of this Mohr circle and you find the diameter of the Mohr circle and afterwards dividing the diameter by 2 we find the radius of the Mohr circle and that value of that radius of Mohr circle is nothing but the maximum shear stress because you can see from the image itself. Now one of the interrelation that is the sigma square plus tau square equal to a square that is the radius of the circle square is also get established from this diagram only. Okay, now I will discuss some interrelations which I am talking about earlier. So what are these interrelations? So I think so that diagram all of you understand very clearly, and how the sigma 1, sigma 3, radius, everything I have discussed. So now I will move ahead with the interrelation, that is the sigma p1. If we say sigma x, sigma z is known to one us, and tau x z is known to us, it is not about the x z. It depends on the plane which we are considering. We are considering xy plane, it will be xy. If we are considering yz plane, it will be yz. Over here we are considering xz plane. So the sigma p1, that is the principal major principal stress, will be sigma x plus sigma z by 2 plus root under sigma x minus sigma z by 2 square plus tau x z square. Similarly, sigma 3, that is the minor principal stress, will be the sigma x plus sigma z by 2 minus root under sigma x minus sigma z by 2 का whole square plus tau x z square. Over here, the sigma P1 and sigma P3 are the principal stresses. Also, sigma P1 plus sigma P3 equal to sigma x plus sigma z is one of the condition it will satisfy. When we talk about the angle, when we talk about the angle at which it will going to act, you can see the interrelation, that is the tan 2 theta equal to 2 tau xz by sigma x minus sigma z. Now you would see I will solve some small problem on the basis of this interrelation which I have established, and you will see that these problems will how much simple and how much interesting, which has been based on that only the simple problem I have found by myself. Like the first question is over here, now find the origin and radius of the Mohr circle of a given state of stress. Also find the principal stress and draw the Mohr circle. If you understand that circle which I have shown two slide before, you are able to find it very simply. We know the radius of Mohr circle is sigma x minus sigma z square plus tau x z square. So when we are going to solve it, we are able to find the radius as 15, and the sigma P1 is equal to sigma x plus sigma z by 2, as we remember, that is sigma P1 and sigma P3. I think so. I will show you again that interrelation, that is sigma x plus sigma z by 2 plus root under sigma x minus sigma z by 2 square plus tau x z square. This interrelation is there. You see, sigma P1 and sigma P3 interrelation is there in this slide, and this same relation is used to find the principal stresses. In our question, only compressive force of 30 units, that is maybe 30 kilonewton per meter square is acting. I have considered it in units only so that you don't get too much confused. So over here the value of sigma z is minus 30. As you can see, sigma z direction, the applied force stresses is in compression, that is the minus 30. So when we calculate our value, we are able to find the sigma P1 and sigma P3 as 0 and minus 30 respectively, and afterwards it is also plotted on sigma and tau axis. Over there the sigma is the x-axis and tau is the y-axis, and you can see that the radius 15 has been plotted over there, minus 15 0 has been represented, and 0 0 of the major principal has been shown, and the minor principal is minus 30 is shown. I think so it is very much easy and everyone understands it very clearly. So I will move to next problem. If you have any doubt regarding this, you go through this slide and this slide very significantly, and you are able to solve this problem very easily. And if still the problem remains there, you can ask me in the next class. I don't think so any problem will be there if you go through those two slides. See, another problem is same problem is there. Just one change I have made in this problem, that over here the 30 is in the tensile direction, as over in the previous problem it is compressive. So result get completely changed. Our Mohr circle gets shifted to the right direction, as you can see from this picture. Again, the radius has been calculated in the same manner as sigma x minus sigma z by 2 square plus tau x z square. By calculating this, We found value of tau as 15 and sigma P1 as plus 30 while sigma P3 as 0. So we are able to find the value of the Mohr circle's radius as well as the major and minor principal stresses. Over there, if someone is able to find the center, so they can also find as 15 only because okay, the center has already rectified shown over here with the help of 15 and 0, and that is the radius. The radius is also presented from the above table in the above section over there. The 15, the calculation has been presented. Okay, no problem. I will move to the next problem. In the next problem, you can see the 30 is applied from the all direction in the tensile manner. Now what changes we found? We found that the radius is found to be 0. If the radius is 0, then it must be a point Mohr circle. See, the value of sigma P1 is also plus 30, sigma P3 is also plus 30. So the circle has been presented as point as it has been shown from the arrow. The 30 0, that point is the major as well as the minor stresses. So I think so its understanding to you is very much clear. I will repeat this again. In this question, the question said that find the origin and radius of Mohr circle for this given state of stress and also find the principal stress and draw the Mohr circle. So over here you can see that a soil mass is there or a specific mass is there on which a tensile force is acting from the all direction, that is the x direction as well as the z direction. So in this case the value of sigma x and sigma z both is 30 and both is positive, and we know our interrelation as sigma x minus sigma z by 2 square plus tau xz square, root under will be the radius. So the 30 minus फिर sigma z is also plus 30, so sigma z 30 minus 30 by 2 is 0, so its square is also 0, so the radius of Mohr circle is come to be 0. Now we know the interrelation as sigma p1 equal to sigma x plus sigma z by 2 plus root under sigma x minus sigma z by 2 का square plus um, tau f z का square. So this interrelation we are very much clear that the sigma x plus sigma z by 2 is going to be 30 and sigma x plus sigma z by 2 is going to be 30, but the value of tau, that is the sigma x minus sigma z by 2 square plus tau x z square, is going to be 0. Hence the sigma p1 is also plus 30 and sigma p3 is also plus 30. So the Mohr circle has been found with a radius 0. Hence its is represented in the figure. Okay, I think so up to this everyone is clear. Now see again, a next problem is there over there in the x direction. The stress has been applied in the compressive manner, while in the y direction the stress is applied in the tensile manner. And over here we made our calculations to find the origin and radius, and afterwards we draw more circles. So over here also you can see that the radius is found at sigma x minus sigma z square by 4 plus tau x z square. So over here you see tau x z is 0, so one is plus 30 and another is minus 30. So 30 minus 30 by 2, that is nothing but 30, and 30 square root under 30 square is also 30. So the radius of Mohr circle is 30. But how to find sigma p1 and sigma p3? So over here you see the value of tau is found to be 30, but sigma x plus sigma z by 2 is going to be 0. Okay, so the sigma p1 value is going to be plus 30 and sigma p3 value is going to be minus 30, with the center at origin of the xy plane at 0 0. So you can see it very much clear from this diagram that the value of origin is 0 0 and the Mohr circle radius is 30 unit. I think so. By going through these four problems based on the slide number 25 explanation, everything is clear in everyone's mind. If still there is any doubt, you can ask me. Once you go through this presentation, I will share this presentation with you with the help of the Google Drive, and I will upload this video on YouTube as well. So from there, if you go through again, if you are the first time listening this concept, it might be little bit tricky for you, but it is a very simple thing if you have the knowledge of strength of material also. If so, also you can get it. But if you have if on any difficulty, you go through these four problems, you get expert in this Mohr circle. This is the very basic problem I have taken. We can also take the more complex problem, but if you understand the basic problem, you are able to solve the complex problem. So that's my viewpoint with my understanding that if we are able to solve the easy thing, we can deal with the difficult thing as well in the future. So it is very much important to be take the thing in a smooth manner, in a step by step manner. First of all, solve the easy problem on the any aspects. Afterwards, go into the complex aspects. So we will solve the complex problem as well. But at this point of time, I think so. These four problems will be understood by everyone, and I think so. If any doubt is there, you can ask me in the next class after going through this four video. So that will not be a problem. Okay, now we talk about the application in civil engineering. So the example of infrastructure development in hilly terrain, cutting slopes, and creating the examples of infrastructure development in the hilly terrain, cutting slopes, and creating the benches of the roads and the pavement. The importance of understanding the critical state of stress in such situation and the real life cause study of the stabilizing slope and the construction of retaining walls. So these are the basically its application is not limited. Its application is unlimited in itself. I have discussed it from very first time that when we are talking about the shear strength, it will be applicable to one and all field wherever any construction work is going on. Without knowing the shear strength of soil, we are not able to move a single step in our study because the shear strength is one of the most important aspects which one need to understand before taking the design or construction activity at any field. Okay. Now I will add one more point like what just I will explain to you that is what do we mean by the passive and active state of material. Just for information, just listen this and afterwards I will show you some problem. So what I am talking about, I will write this also during my giving you presentation file, but right now just listen like when we talk about the generalizing law, so the expressing the stress in terms of sigma 1 and sigma 3 and analyzing the situation where the lateral stresses are more or less then the vertical stresses. So the passive and active state of earth pressure. You know, you have studied about the earth pressure or maybe you have listened about at least. So we know that when we talk about when the stresses in the x direction, if we consider this as x and this as z, basically vertical as z and horizontal as x. So if the stresses in the x direction is more than the z direction, so that is the passive state of stress. You know sorry, you know, excuse me, give me a minute. Okay, see, so what I'm talking about, I'm talking about the active and passive state. So you know very well. I think so. You everyone of you are aware about the active and passive state. So when some stress is applied in such a manner that the if some support is there in the horizontal direction, and that support is moving toward the soil mass, the state of stress is said to be passive. Over there, the stress in the x direction. Basically, if suppose this is a wall, my hand is visible, I think so. If it is moving toward the soil, and over here the soil mass is there, if it is moving toward the soil, the stress in x direction will be more. In that case, the value of sigma x will be more as compared to sigma z. So it will result in the passive state of stress. Similarly, if this is the soil mass, and this is a wall, it's moved away from the soil. Basically, soil is throwing it in that direction. It will ultimately result in the active state. So you can interrelate this point that what do we mean by active and passive state and how it will be related to sigma 1 and sigma 3. This is not the part of syllabus at this point of time, but as one aspects I have just want to discuss it, so I will discuss it. I will move ahead, and I will add some point in this, like the we talk about the pool. Pool is a point on a Mohr circle. There is a point on the Mohr circle which is said to be pole, which all the planes will pass. A point on the Mohr circle from which all the plane is passed is said to be pole, and the pole represent the state of stress. Pole represent the state of stress on the plane inclined at the some orientation in the space, drawing a line parallel to known state of stress on a plane through the Mohr circle. And when we talk about the reverse process of this, the drawing the line passing through the pole determine the state of stress on a plane. If we draw the line passing through the pole, it determines the state of stress on that plane only. Okay, so now up to here I think so you have listened everything. Now I will show you some more aspects like the generalized state of stress. We talk about the generalized state of stress, and what do we mean by this. So when we talk about the generalized state of stress, uh, generalized state of stress where the compressive and tensile stress act on the soil element, and the shear stress is also present with the positive value for the clockwise direction and the negative value for the anti-clockwise direction. What do we mean by that? We will see with the help of problem. And the orientation of the major and minor principal stress is determined using the Mohr circle. And how we will determine, we have seen very good examples based on this concept earlier slide. Okay, now I will take one more problem, a very good problem, so you will get a better understanding about these aspects. So let me discuss this problem before moving ahead. So I think so we have only 10 minutes left and I have lot to cover. So we have to move little fast because I want to cover the entire thing which I have made for you for the today class, so that in the subsequent class we can discuss a new thing. I don't want to left anything at this point of time. Okay, so whether my screen is visible? Okay, I think so. Hello. Okay, okay, okay. I think so. It is visible. So you can see the state of stress at a point at 35 degree using the analytical method. When we talk about this problem, so you can see over here the compressive stress is applied of 12 and the 52 on a soil mass, and 35-degree arc plane is also shown. The shear stress is acting in 0. So when you are going to found the origin, that is the sigma 1 plus sigma 3 by 2 plus 0, so you can find the origin of that point, and as we have discussed earlier, tau as sigma x minus sigma z by 2 sin alpha, the value of sigma x is compressive, that is minus 12, and the value of sigma z is 52, which is also acting in the compressive direction, so its value is also going to be minus 52. And as we know the interrelation sigma x minus sigma z by 2 sine 2 alpha, the plane on which we are going to calculate the shear stress and the normal stress, act at the 35-degree plane from the horizontal. So that alpha is going to be 35, and when we are calculating the 2 alpha, the value will be the 70 degree, and the value of shear stress is found to be 18.79 kilonewton when you do the calculation. In a similar manner, the sigma value is said to be sigma x plus sigma z by 2 plus sigma x minus sigma z by 2 cos 2 alpha. And if you remember, the interrelation has been shown in the slide number, every slide maybe around 30 or before. I don't remember at this point of time, but I have shown the interrelation earlier. So you can find that this interrelation is used over here in order to find the shear stress and normal stress at a plane 35 degrees from the horizontal on this given plane, on which the stress in the x direction is act to be 12 and in y direction act as 52 in the compressive direction. Over here, the origin is also found as sigma 1 plus sigma 3 by 2. That value is going to be minus 32, and the y coordinate is always 0 for the origin, because the origin of the Mohr circle is always act on the x-axis, that is the normal plane. I think so up to this point. In this problem there is no confusion for anyone. I think so. Okay. Now you can see another problem. This problem is visible to you, I think so. So in this problem you see that the stress in the x direction is apt to be 50, in the plus 50, that is in the tensile direction if one would say, and in the y direction it is plus 100, but along with that the stress is also acting, shear stress is also acting as 25. So how and what the problem is asking. So over here I have not written what you need to find, so I will see you over here as well. We have to find the principal stresses, major and minor principal stresses. So in this problem, we are going to find the major and minor principal stresses. How we are going to find the major and minor principal stresses? So we use our interrelation only, sigma z, sigma x, tau x, z is known to us, and sigma p is calculated using the interrelation, that is the sigma x plus sigma z by 2 plus root under sigma x minus sigma z by k square plus f z k square as sigma p1, that is the major principal stress. The plus minus has written and the calculation has carried out over here to find the value of major and minor principal stress, which is found to be 110.36 kilonewton per meter square and 39.64 kilonewton per meter square. Over here, everything is presented in a very clear manner. So I think so there will be no doubt in anyone's mind regarding this. So I will move ahead from here, and you can see some more thing also guide out over here, that is the tan to theta, the angle at which it will be acting is also found, that is the 112.5 degree. So I will explain this in the subsequent class because it will take some time. So I don't want to leave anything left. So I will carry this in the next class. So you see the different one more problem is over here, which is also a complex problem. So I will discuss it quickly. You go across this problem in your as a homework, and you can ask me in the next class. So you can see over here, to determine the magnitude of sigma p1 and sigma p3 using the Mohr circle. For the Mohr circle, plane AB equal to sigma x equal to 50 kilonewton per meter square, tau xz equal to minus 25, and sigma z equal to plus 100, and the tau xz equal to plus 25. Whatever be, it has shown over here for the stress. Mohr circle is plotted over here in this figure B given below. So over here you can see that the origin is found to be 75, that is first of all, we have found sigma p1 and sigma p3. On the basis of that, You can see sigma x minus sigma z by 2. Okay. Um, I will also explain this in the next class only because it also requires some time. I don't want to accelerate it. So you can go ahead with the solution, but I will discuss it in the next class. I will first of all focus on finishing the today lecture in time so that the problem is not there if the sometimes it's also happened that lecture get closed as the time get over. So I don't want such cases. So I will move ahead first of all. So we are talking about the Mohr-Coulomb failure criteria. The functional relation between the normal and the shear stress on a failure plane can be given by as a shear strength as a function of stress. We also know that the Mohr-Coulomb failure criteria in the relation is given as shear stress at the failure as sigma equal to shear strength equal to C plus sigma and tan phi. As I have discussed earlier, very starting of the today class, I have said that the cohesion and angle of internal friction are the two of the most important parameters which one need to be understood before stating any point regarding the shear strength. And as we know, these parameters are the most important parameter which could not, which must be found with the help of the testage, which are said to be performed on soil in order to find the. So the interrelation is like S equal to C plus sigma and tan phi, where C is the cohesion and phi is the angle of internal friction. When we talk about the shear strength, so the shear strength will be plotted on the y-axis and normal pressure on the x-axis, and the interrelation as given as S equal to C plus sigma and tan phi. So the phi is the inclination, basically the angle which it made with the horizontal, and C will be the cohesion intercept, and afterward the interrelation established as S equal to C plus sigma and tan phi. I think so this thing is clear in your mind. Now I will state some key terms. We talk about key terms. So what are the key terms? Some are the terms which we need to understood like the shear strength. So first of all, I will define in one line the shear strength of a soil is the maximum internal resistance to applied shearing forces. The effective friction angle. What is the effective friction angle? Phi. We say C dash and phi dash. That is the effective friction angle and effective cohesion. We will discuss that what is the difference between the C dash, phi dash and C phi. But at this point of time, the effective friction angle is a measure of shear strength of soil due to friction, and the characteristics, cementation characteristics is one of the point key term, that is the cementation is a measure of the shear strength of soil from forces that cementation process apply in order to give a specific strength. So that's not an important point. Leave it. Cohesion. Cohesion is a measure of intermolecular force. As it is discussed in the very early of the today class, we say that the cohesion acts due to the intermolecular forces. And the cohesion and apparent cohesion is the 2 points. So what do we mean by the apparent cohesion? It is also one of the important things which we need to understood. So apparent cohesion is the apparent shear strength and zero normal effective stress. As we see, the zero normal effective stress will be the stress over the y-axis. So at that point, the cohesion is there. That is said to be the apparent cohesion. And the two more point is the critical state. Critical state is a stress state reached in the soil when the continuous shearing occurs at the constant shear stress to the normal effective stress ratio and the constant volume. Dilation is one important point, that is the measure of the change in the volume of a soil when the soil is distorted by shearing. Okay, so now I will conclude the today lecture with discussing what are the outcomes we bring from the today lecture. So I will say it very quickly. So first of all, we have discussed the course Geotechnical Engineering 2 that focuses on understanding the shear strength of the soil. So we today understand the shear strength of the soil. The Mohr circle is also one of the valuable tool for analyzing the state of stress in the geotechnical materials. And the another concepts that learned in this lecture is the engineers and technologists can make the informed decision in practical situations. So the presentation encouraged the audience to practice the problem solving using the Mohr circle and deepen their understanding in the shear strength of the soil. Now I will leave you with some question which we already discussed in the today class only, but you need to answer this question. I will suggest you to write these questions by yourself before the next class, so you will get a better idea, better understanding of what we have learned today. So the what are the questions I have given for you is like what is the meant by the shear strength of the soil? What are the factors that affect the shear strength of the soil? And what is the Mohr circle? What properties of Mohr circle? And as I have given the four problem over here, so I will say you to solve at least four problem from any book based on the Mohr circle. And with this, I will sum up the today's session. Some of the reference book you can prefer is like this, which has been shown in the slides. And with this, I will sum up the today's session. I think so. This lecture found to be helpful for all of you, and I will add one more point in the end for everyone who are here or maybe going to attend this course on the YouTube. Is that please be go through the lectures and content and solve the problem as much as you can. The similar problem which we have discussed today in the class and we are going to discuss in the subsequent classes. I will suggest you to go through those problems. In the upcoming classes, we will going to solve some MCQ problem as well, very easy MCQ problems, so that you can get a better understanding, better knowledge based on those aspects. So I will end up my session over here and thank you very much everyone for attending this. With this, I am ending the today's session. Wish you a very happy weekend. Thank you very much.